part 2 of lesson 7.5. You guys wrote these theorems down that we're going to talk about yesterday on the front page of your notes. Okay, this is called the side splitter theorem. Okay. What this means is we have 3 parallel lines, and then we have these 2 lines that are called what? What are the 2 lines called that cut through parallel lines? Transversals. Okay, so we've seen those before. What this theorem tells us is how we can set up a proportion to help us solve for missing sides. Okay, so they have AB over BC equals DE over EF. Remember, proportions work multiple different ways, just as long as your relationships are consistent. Okay, so here they wrote AB over BC equals DE over EF. Another way we could write that is I could put AB over DE, so this side over this side, equals BC over EF. Okay, now let's explain why this works again. If I cross multiply this side, I have AB times EF equals BC times DE. If I cross multiply this one, I have AB times EF equals BC times DE. Do you agree these are the same answers? You agree those are the exact same answers? Okay, so like I said, proportions work one of 2 ways as long as your relationships are consistent. Okay, they work side to side. They work side to side, or they work up and down. Okay, they work the same way. So it might not be all the time where if you look at your neighbor, see how they set it up, you could set it up differently but still get the same answer. Okay, so every time I set up a certain proportion, you very well could have set it up a little differently. All right, so what I want to look at is that number 3 here. This is your example 3 in your notes. I want to find R. Keep in mind they told us that all of these were parallel to each other, and these serve as our transversals. Okay, what's a ratio that I can set up for R? What does R relate to?
6.
I agree with you. Okay, I can do R over 6. What's a full ratio I can set that up to find the value of R? Exactly. Yep, 3 over 7.5. So we did this side split. Okay, so R over 6 and 3 over 7.5. What else? What's a different way I could set that up? What else could I relate R to?
2.5.
With these same numbers.
R over 6. Oh, wait, R over 3.
R over 3 equals.
6.
Yep. So all of these, those are the same exact thing. So if I cross multiply here, I have 7.5R equals 18. Help me out. If I divide those, what do you get? What's 18 divided by 7.5?
2.4.
I heard 2.4.
2.4.
Remember on tests, I won't be very picky about how you round things, just as long as you're in general ballpark range. Okay? So R is 2.4. Now let's do the same thing for S. What is a ratio I can set up for S? Let me fill this in. This right here is 2.4.
2.5.
I heard 2.5. Okay, so we did this relationship. What else can I do?
You do 3 over 7.
Okay, I'm going to ask you this. Can I put 3 on the top, or does 7.5 have to go on top?
7.5.
Why 7.5?
It's on the same side.
Because it's on the same side as S. Yep. So I'm going to do 7.5 over 3. Could I have used a different ratio here? Which one? Could I have also used 6 and 2.4? I could have also done that as well. Okay, so if I cross multiply, I have 3S equals, what's 2.5 times 7.5?
18.75.
18.75. What do you get when you divide?
6.25.
6.25. So I want to look at, okay, this kind of puts the 2 relationships together. So I want to find this length first. Okay, let's practice finding a missing side. Start with this. What can I relate x to? I could do x over 10 equals, so that was this side. Think of this side. What's a ratio I can set up?
7.5. 10.5 over.
Yep, it'd have to be 10.5 over 7.5. Hey, someone help me out. What's 7.5x divided, or sorry, 105 divided by 7.5? What'd you say? 14. So what that just gave us is this missing side length right here is 14. Looking at your part A real quick, it says, are these two triangles similar? Is our little triangle similar to the big triangle? What do we know about overlapping triangles?
They have a shared side.
They have two shared sides, right? And a shared angle. So are they similar, like what we talked about yesterday? Yeah, if they overlap and all those triangles are inside each other, those are all similar to each other. So B is yes. A is yes. Looking at part B, it wants to know if these two angles right here are congruent to each other. What do you think? Are these two angles congruent to each other? What if I show you this?
Yes.
Now, why do you say yes?
Because there's a way. Oh, wait. Oh, because they have two shared, so the same side. Angle bisector.
What kind of triangle is that?
Isosceles.
Isosceles triangle, yep. So your reasoning for that? It's an isosceles triangle. So that means if two sides are the same, those two base angles are the same. So yes, they are congruent to each other. Okay. I want to look at this first. What does it mean? So this is called the triangle angle bisector theorem. Kind of a mouthful. But what does angle bisector mean to you when you hear that?
Bisects an angle.
What does it mean by bisect?
Half.
Cuts an angle in half. Which of these lines in this diagram is the angle bisector?
X and V.
X and V, yep. Right here, that's our angle bisector because it splits that angle in half. I want to ask you, does that mean that these two sides are congruent to each other? No, okay? Angle bisector has nothing to do with the side that it's going through, okay? All it has to do with it splitting this angle in half, okay? So, similar to what we've been doing, setting up a proportion if we wanted to find missing sides, as in finding any of these missing sides. Okay, so what they set up is ux over wx equals uv over vw. Okay. Another way I could write that to get the same thing, I could do ux over uv equals wx over wv. Again, you would get the same answer as long as you keep your relationships the same. Okay. Example 4 first. I want to look at this one together first. If I wanted to find x, well, what can I relate x to?
10.
I agree, I can do x with 10. I also heard 13. Okay. 13 is this whole side, right? Do you agree?
Yeah.
Okay. I want to find what this is.
Then you put 13 over.
Because that's what I need to put here. How would I figure out what this side length is right here?
13 minus
It would be 13 minus x, right? So if I put a normal value in for here, if I put 2, how would you find CD? You take 13 minus 2. So for my setup here, I can take 13 minus x over, what does this side 13 minus x relate to? 16. Okay, so if I cross multiply here, I have 16x equals, what do I have to do on this one? Yep, so I get 130 minus 10x. Someone help me out. What's 130 divided by 26? X equals 5. So what would the length of AD be? 5. What would the length of this be?
7.
I would get 13 minus 5 to get 8. Yep. All right, now let's look at your example that is in your notes. So, again, if you don't set it up exactly like mine, just make sure your relationships are the same if you cross multiply. So, if I start with, let's say, 3x plus 3, what can I relate 3x plus 3 to? I can relate it to 18. Okay. Again, don't erase what you have until I talk about both options. What would come on the other side?
3x minus
3x minus 7 over 12. Okay. I'm going to write a different example over here. If I started with 3x plus 3, what else can I relate it to other than 18? 3x minus 7. So then the other ratio would be 18 over 12. Again, if you cross multiply both of these, you should still get the same answer. Okay. Let's walk through how to solve for x here. What are we going to have to do on both of these? Distribute. So 12 times 3 is 36. 18 times 3 is 54. What's 18 times negative 7?
Negative 126.
Negative 126. What can I do to solve this? I subtract 36x. Yep. 54 minus 36 is 18. Mm-hmm. 162. What's 162 divided by 18? 9. So that's your part A. X equals 9. Part B, it wants to know what are the values of GH and GK. Right. GH, if I plug 9 into here, what's 9 times 3? 27 plus 3? 30. So GH is 30. GK, if I plug that in, what's 3 times 9? 27 minus 7?